Rain not appearing.
Rain never shows up when you need it.
To evolve my Sliggoo, but I cannot find rain literally anywhere.
Any way to force the rain or figure out where it's raining?
Sliggoo in your party never
Does
rains.
it rain more often in certain areas? Rain is just a random occurrence.
It's absolutely brutal is what it is. I just got a Sliggoo and it hasn't rained in my game in 3 real days. It's always sunny in Paldea. Pokemon is a game of legends, epic battles, and some of the driest farmland I have ever seen. And if you need rain to evolve your Pokemon, well, congratulations. You've just signed up for the world's most frustrating waiting room simulation. I swear shiny hunting is faster than this. Right behind me is one of the many biomes found throughout Pokémon Scarlet and Violet. And this map is packed with biomes, each one more unique than the last. So you might think, wow, what a beautiful island. Surely it must be raining somewhere around here. But what happens when you start looking for rain? By the lake? Dry. The grasslands? Dry. What about the forest? Dry again. I'm just trying to get my buddy Sliggoo to be a Goodra. I need him to complete the Pokedex for the shiny charm. Well, here's the thing. In real life, most of the time, it's not raining. And just because something feels like it will take forever, doesn't mean it actually will. I mean, unless your name is Starsis in the video game. That's never coming out. On Earth, it only rains about 11% of the time. And that percentage drops even more if we rule out the ocean. On land, it's only raining on average 8% of the time. But across the globe, that rainfall can really add up. Rainfall accumulation can range anywhere from 0 to 400 inches per year. That's over 10 meters. But what about in Pokemon? Is our impression right? Does it really never rain in Paldea? Is there any variation between the environments here? Does it rain more in the forest and less in the dry canyons? Or is Ditto stuck on a never-ending quest to water all grass in Paldea? You see, if you get to
the next area, you'll unlock the Paldean Wooper, and if you unlock the Paldean Wooper, then you can soak up.
Look, just look it up. Well, my wife and I did months of research into hydrology, rainfall, and why catching those legendary Pokemon at the end of your game might have actually doomed all of Paldea. Yikes. All to figure out how often it rains in Paldea. But to know that for sure, we had to go on a rain quest and document the rain in every single biome. In each of Paldea's 9 biomes, we tracked every rainstorm, snowstorm, and every sudden weather shift the sky decided to throw at us. And if you've watched our Rain in Hyrule video, you know how scientists measure rain. We used this same randomized approach, but this time we did it with your help. See, when scientists have a lot of data to collect, they can't collect it by themselves. Sometimes there is too much data or not enough time to collect all that information without help. And that's where citizen science comes in. It's actual data collection to solve real-world problems. Projects like Galaxy Zoo, where people help classify galaxies, or the Audubon Christmas bird count, which is exactly what it sounds like. 1, 2, 3, 4, 5, 6, 7, 401, 9, 402, 403. And it's somehow much more competitive than it should be. Keep counting, dude. You got this. 408. These kinds of projects let scientists run studies at a scale that would normally not be possible, tracking migratory animals, public health trends, or in our case, the weather in Pokemon Scarlet and Violet. Specifically, tracking the rain in Paldea. And before we go any further, we want to say a huge thank you to our Discord members who helped collect this data. Let me introduce you to 0405 Council. He's pretty cool. Origami Hoshi. she just learned how to surf. The splashing is still fun though. It's just, you can learn to jump from her. Fire booze. Never have to worry about a flashlight or anything. Kelvin. And Pawnee.
Huh?
Together, we spent 63 in-game days tracking weather patterns in Pokemon Scarlet and Violet. We timed it, categorized it, and logged every rainstorm and snowfall event, just like actual meteorologists. As a team, we divided Paldea into 9 clusters based on their biomes, and randomized our location once every in-game day. That means every 24 hours in-game, we packed up, healed our Pokemon, and each randomly selected a new biome to observe. Just watching the sky for 72 minutes straight. And yes, that's as boring as it sounds. Just ask our Discord.
Sandwiches. What sandwich shall I make next?
But that's not all. The group approach meant that we could collect data at different points throughout the school year in Paldea. From fresh starts to fully completed games, we were able to randomize our measurements across time and space. No Palkia and Dialga needed. And randomness is key. There aren't visible seasons in this game, but it's important to measure as much of the variation as possible, even if we can't see it. You can't just look at the places or times it rains and call this place New Tatooine. We categorized rain into 2 intensities, moderate rain and lightning storms, and snow into light and heavy snow. Then we used intensity and duration to calculate accumulation across all of Paldea. And based on these calculations, we classified each region as orange. It gets less than 10 inches per year. It's probably a desert. You won't be needing an umbrella here. Green. 10 to 60 inches per year. This is a sweet spot. You probably live in a green zone, maybe along with this guy. Light blue, 60 to 100 inches per year. It rains a lot here. I hope you have some really nice rain boots. Dark blue, 100 to 400 inches per year. It's getting excessive. You better get a Pokemon with the move Sunny Day, because you're never going to see the sun again. Or purple. It rains more than 400 inches per year here. That is more than anywhere on Earth. This is cataclysmic levels of danger. I hope you taught your Lapras surf. What do you mean I need at least 5 badges for me to ride you? You can use surf in battle. Literally in battle as a move. It's because I'm fat, isn't it? By the end of our journey, we will have a fantastic visual map of just how much or how little it actually rains in Paldea. And let me tell you, what we found caught us off guard.
Boo.
Okay, sorry. Let's fly into the research.
Boo. Boo.
Dive, I meant. What Pokemon move do you want? We start our journey to the north, in the beautiful lush grasslands around Casaroya Lake. And if Reddit knows anything, this northern grassland is going to be the best place to look for rain. And that makes sense, because we know Paldea is based on Spain. Northern Spain is lush and green due to its high rainfall. In fact, some northern regions like San Sebastian can get rain to upwards of 180 days a year. That's half a year. So will the northern grasslands follow that trend? Well, time to stand in this field and find out. Ooh, someone pooped over here. Whoa! Oh my God, Tauros, leave us alone. Another one? Ah, Tauros again? Dude, leave me alone.
5 minutes later.
I wonder what sandwich I should meet. I wonder what Nemona's doing right now. Probably harassing some trainers for about... Tauros! Leave me alone! I'm trying to do science! Stop attacking me! wonder why they didn't let you battle the Elite Four again. Is it because Hansel started... That's it. Fire boos, go. Burn them all!
Stop it. Get some help.
Fire boos used incinerate. It was super effective. Good job, fire boos. They won't be bothering us anymore. Where was I? Oh, right. Standing in the field for hours and hours. Well, while we were staring at the sky waiting for rain, we noticed something odd. The clouds don't move. And what's even crazier is that there are moving shadows on the ground that don't match any of the clouds in the sky. This development choice is almost as bad as the windows in the other Pokemon game. You know, odd video game design choices aside, how does the weather around here work anyway? In the real world, clouds are always moving, even if it's slow. The tiny water droplets and ice crystals are being constantly pushed around by wind and changing pressure. That means even if they don't seem like they are moving, clouds are at least changing shape. And we see that in the fog coming off the lake here. But if the high elevation clouds aren't changing, how does it ever rain? See, most of these clouds are cumulus clouds. There are also some higher and thinner clouds that look like they could be circumcumulus. Oh my gosh. I'm gonna be real with you guys. I'm not a weather person. Okay, I mean, like, I like weather, but like clouds, I'm not.
We are looking at how to pronounce the name of this type of cloud. We'll be looking at how to say more clouds names as well. Stay tuned. Cirrocumulus. 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 Stress on that third Q syllable. Cirrocumulus. And now you know. More videos for you here to learn more. See you there. Thanks for watching.
Look, I'm from Appalachia. Oh man. Insert your favorite Appalachian joke here.
Things found written in hillbilly fortune cookies.
Hell, I can't read.
By the way, that guy, that was a YouTube video, not Google, not Gemini, YouTube video. That guy has 2 million subs, which is absolutely insanely cool. That a guy who is just getting him to say cirrocumulus has 2 million subs. Props to that dude. Here's his YouTube channel right here. Go check him out. And maybe if you like our content at all here, maybe think about liking and subscribing to this video because it helps our channel out. Although I'm teaching a lot of things, maybe not as cool as the cirrocumulus pronunciation, but anyway, there are also some higher, thinner clouds that look like they could be cirrocumulus. Both of these are sunny day clouds, formed from warm, rising air. These clouds should never produce rain. Maybe it never rains in Did those rain clouds just pop in? Just no warning, just straight to get inside. Man, being a weatherman in Paldea here must be really fun. So what did all that rain give us? Well, after days of standing and timing, we found that it rained about 70% of the days we spent in the northern grasslands. That's amazing. I mean, it's a lot more than real world Spain. But if you watched our Reign of Hyrule video, you know that it rained every single day in every single biome. It's crazy. You gotta, if you get a chance, it's like one of our biggest videos on this channel. You gotta go watch that if you haven't. Anyway, here, that is way less rain than Hyrule, which is good news. We also saw one lightning storm here, which means one bout of heavy rain. But how much rain does that equate to? Well, in a normal rain on Earth, it can rain between 0.3 to 1 inch per hour. And in big storms, it can rain 1 to 4 inches per hour. So we estimated 1 inch per hour during lightning storms. For each rain, we timed how long it rained and divided by 72 minutes. That's the length of an in-game day. Then we multiplied that percentage into 24 hours. We found that it rained on average 1.1 hours per day. And that actually doesn't seem like much. But when you multiply that rate by 365 days in a year, we found that the northern grasslands received about 162 inches of rain a year. That's over 4 meters, and more than double the wettest parts of Spain. And so, this is getting a solid blue on the map. Maybe Kofu has a boat we can borrow. After the beautiful lakes to the north, our journey took us south to the Sado Desert, and it is dry here. I mean, there is literally no vegetation, unless you count Bramblin. And well, he's looking a little parched. But hey, that's just how he rolls. Boo! Boo! Boo!
Oh, brother, this guy stinks!
Oh, come on. That one was funny. And why not? There is literally a river running along the edge. Where are all the plants? Do you think people are walking across the bridge and weeding the desert to maintain the aesthetic? I mean, can you imagine? I say this because in the real world, deserts do get some rain, and most have a lot more vegetation than you would expect. Even the Atacama Desert in Chile, which is renowned for being the driest hot desert on Earth, gets about half an inch of rain per year. I mean, NASA literally uses that place to simulate what it's like being on Mars. But even it has some vegetation on the outskirts. So with no vegetation in the game, is that what we should be expecting? Half of an inch of rain or less? Well, that's exactly what we found. Across all our days here, it never rained. It does get some serious sandstorms, but absolutely no rain, which raises a very important question. Is no rain like that? Is that even possible? I mean, can a real-world place really get no precipitation? Well, as it turns out, there is only one place on Earth where that does happen, and that's the McMurdo Dry Valleys in Antarctica. Not to be confused with the awesome McMurdo Ground Station, folks. That's a different area, but I really like them. I actually used to work with them. They're cool. These valleys are so dry, they haven't experienced measurable precipitation in about 2 million years. You heard that right. 2 million years. Which means the last time it rained here, early humans were still figuring out how fire worked. Whoa. So how does that actually happen? How do you get a place that dry? I mean, I'd really have to pack a lot of lotion if I came here. Luckily with YouTube magic, I can just teleport here and teleport out. Kind of like when Doctor Strange ended up on Mount Everest. Except I'm not actually there. Although, you know what? I am actually here.
How?
Well, the answer is something called climatic winds. Here's the idea. At the top of the mountain or high plateau, the air becomes extremely cold. And when that air gets cold, it gets dense and heavy. And that dense, cold air doesn't just sit there. It's heavy enough that gravity pulls it downhill. And as it descends, something really interesting happens. The air expands and begins to warm? Yeah, and that warmer air can hold much more moisture than colder air. But that doesn't mean it suddenly becomes humid. It means that relative to when it was cold, the same chunk of air is now drier because its capacity to hold water has increased. So instead of condensing into clouds, it does the opposite. It absorbs moisture. And that descending warming air pushes out any potentially moist air sitting in the valley. It replaces it all with warm air that is dry and very uninterested in forming rain clouds. The result? There is never enough moisture to produce precipitation. No clouds, no drizzle, no dramatic thunderstorm soundtrack. You've been thunderstruck! That's Pikachu's favorite song. And that's how you create one of the driest environments on Earth. Okay, great. I think. But could that be happening in Paldea? Could Cataclysmic winds be sweeping down from cold highlands to dry everything out? Well, no. There are elevated regions nearby, but they aren't that tall, and they certainly aren't cold. There is no way a region surrounded by lush grasslands and a town literally full of waterfalls could be this dry. But no rain here means we have to give this an orange rating. As we continued south from the desert, we found more grassland. Grassland is a pretty broad category and is simply defined as having mostly grass. Duh. But on Earth, there are a ton of variations like steppe and savanna, and each of these have a different ratio of grass to trees. And that difference is driven by rainfall. So what about in Paldea? Well, the northern grassland had many more trees, and the trees were actually larger. And in the south, the trees are further apart and scattered. And that actually makes sense. See, in the real world, latitude is a major driver of rainfall. If you watched our videos on the rain in Hyrule and the shape of Zelda's world, then you already know that there are global circuits of air that move moisture. We already talked about Hadley cells in those videos. But north and south of that, there are also feral cells. And then we have polar cells. These circuits mean that precipitation usually comes in bands north to south. The other factors like mountains and ocean currents do the rest of the work. So what about in Pokémon? Well, based on the spread of trees, we were expecting the southern grasslands to be a bit drier than the north. And that seems plausible because it rained a lot up north. Well, it turns out that the southern grasslands were the only place in Paldea where it rained every single day. That's not a great start. But we also didn't get any lightning storms down here. So the rain was always nice and steady. It rained an average of 2 hours per day, which means the southern grasslands of Paldea are getting around 182 inches of rain per year. Oh boy, that's a good bit. That's even more than the northern grasslands. And I'm starting to wonder why Paldea is in a tropical jungle at this point. Another dark blue on the map. If you were wandering around the southern grasslands of Paldea, you might have noticed that right in the middle lies a dried up farm. It's super weird, right? Dried up grass, but the trees have leaves. It's almost uncanny in a way. And what's amazing is this is clearly modeled after the agriculture of southern Spain. Spain is one of the largest exporters of citrus, olives, and almonds. So is there any way to know what kinds of trees these are? I mean, Pokémon Scarlet and Violet is not known for its highly detailed graphics. Is this just all one texture copied and pasted over and over again? Well, it turns out they did okay here. I mean, sure, the grown-up trees have a generic blobby leaf texture. But when we look at the saplings, we get some important clues. The leaves are evenly spaced along the branches, and each leaf emerges opposite from another. instead of alternating along the branch. This is a key indicator naturalists use to identify tree species. So, do any of the agricultural trees of Spain have evenly spaced and opposite leaves? Well, it turns out, yes, olives do. You see, orange trees and Mediterranean almonds have alternating leaves, so it can't be those. And sapling citrus trees often have leaves that are clustered rather than evenly spaced. Plus, I don't see any oranges and almonds around here. And to add even more evidence to our theory here, this place is overrun with smolives. You know, the olive Pokemon. I wouldn't want to work in this orchard. I prefer my fruit in the non-sentient variety. And if we look around, this actually looks like a classic dry ground olive orchard, which is super cool. The south of Spain doesn't get rain year-round, and the agriculture areas only get less than 39 inches or 1,000 millimeters of rain per year. But that's mostly in the winter. From June to August, there is almost no rain, and that's why most modern olive orchards irrigate their trees. But some growers still practice dry ground farming. This ancient technique forces trees to grow deeper roots and rely on groundwater reserves. There are a few telltale signs of this technique. Farmers use wide spacing between the trees to reduce competition for water. They also use mulched olive clippings to reduce water loss from the soil. And that's exactly what we see in game. Spaced out trees in a dry area with mulch applied between the trees. So is all that necessary? Is it so dry in this place, in this region of Paldea, that rain can't support a full orchard of trees? Well, surprisingly, this is one of the driest places we found in the game. Yep, go ahead. You can clap for the Pokemon team. You can clap for them. It's fine, go on, yes. Yeah, I know that we have a lot of Pokemon Scarlet and Violet PTSD, but let's go on, clap, that's actually a good thing. It only rained about 42% of the days that we were there, and for only an average of 43 minutes per day. That doesn't seem like very much rain, but unlike Spain, Paldea doesn't have a dry season. So if we multiply that across 365 days, well, that's still around 79 inches or 2,000 millimeters of rain. And that's twice as much rain as the olive groves in Spain. Can we undo the clapping we just did? Editor, rewind that back. Okay. Maybe winds and waves will be better. And with that, we are going to give the dry farmland a light blue rating. Man, I am actually surprised here. I mean, yeah, it didn't match the real world equivalent, but Pokemon is actually doing okay here. Look at all of this variation. I know it's a little high, but these rain levels could definitely exist in the real world. Surely the snowy regions will keep that up, right? Well, to find out, we headed up to the Glacido Mountains, home of the Ice Gym and the ski challenge that even my 3-year-old can complete. This area is clearly an alpine tundra. Biomes are defined by annual temperatures and precipitation, and usually that depends on latitude. But on mountains, it can also depend on elevation. As you move up a mountain, slope temperatures decrease and wind speed increases. At the base, the biome resembles the surrounding area. A little higher, and we start to see snow and an increase in pines and other conifers. That's montane. But if the mountain is tall enough, above the tree line, you might see alpine tundra. This only exists above 10,000 feet or 3,000 meters, and it is characterized by few or no trees. The climate here is so harsh that only mosses, lichens, and a few grasses can survive. And that's what we see here. A high elevation mountain with almost no trees. In the real world, alpine tundras get on average 39 to 78 inches or up to 2,000 millimeters of snow per year. But some seaside mountain ranges can exceed 100 inches of snow annually. But what about in Paldea? Well, it snowed every single day here for an average of over 11 hours per day. And almost half of that was heavy snow. That means Glacido Mountain is getting on average 2,909 inches of snow per year. That's almost 74 meters. Holy Articuno! What the heck, Pokemon? That's way too much snow. You were doing so well. Even Omari, Japan, which is widely accepted as the snowiest city on Earth, only gets a third as much. And their snow is over 2 buses tall. They're gonna need at least a quadruple decker bus if they want to see over that. I can just imagine Omori, Japan, where they have like a 4-story bus that's just driving through and you just see the top and it's just people like, oh, look at all this snow. Well, I guess we have to add our first purple rating to the map. No wonder there aren't any trees here. Everything is being crushed by the weight of all that ice. But what's odd is there might actually be an explanation for why we don't see a glacier here. Normally, snow builds up in accumulation zones on mountaintops. Eventually, all that snow compacts into ice, forming glaciers that slowly move downhill. But that's not what we see here. Sure, there is a lot of built-up snow, but there are also running rivers and waterfalls. That means the snow might be melting fast enough to avoid glacier formation. There are 2 main methods for a high-altitude glacial melt. The first is solar power. And no, I am not talking about melting ice with that move that takes 2 turns to go off. Come on, Venusaur, get it out already! At high elevation, solar radiation is much more intense. The radiation levels increase somewhere between 4 to 10% every 1,000 feet. So at 10,000 feet, we're talking radiation that is up to 100 times stronger. And then Elsa might not want to build a snowman here. And all that solar radiation means that the snow on the surface melts pretty quickly. That's how places like Yosemite Falls form. The other option for melting is geothermal warmth. As high-altitude glaciers start to move downhill, the friction and heat radiating from the earth can actually melt the underside of the glacier. This causes rivers to form underneath glaciers and flow downhill. And normally, this is a great source of water for people and the animals below. But if the mountain gets 2,000 inches of snow per year, well, the melting just isn't going to keep up. Whether it's a crushing glacier or a flood of snowmelt, the rest of Paldea is about to be in danger. But maybe highlands can buffer some of the destruction of the mountain. The foothills of Mount Glacido lie to the south, and this is a really unique area. Most video games jump straight from lowland to mountain covered in snow, and completely forget that in the real world, many mountains have foothills. Foothills are smaller hills that border larger mountain ranges. Mountains are often formed by tectonic uplift. When 2 tectonic plates move towards each other, the crust is compressed, causing folds and ripples in the landscape. These uplifting forces are often widespread and at lower energy further from the fault line. That means the folds that are further away from the collision zone are generally smaller. Foothills are created by these lower energy folds. You can think of this like 2 cars getting in an accident. The hoods don't just bend upwards. They fold like an accordion. So what's happening in the foothills of the Glacido Mountains? Is it a car wreck over there? Well, this region should have a pretty similar rain to the nearby forest. We would expect a mix of rainfall and snow as we move up the slope. But is that what's really happening here? No, because it turns out that it only snows here. But that might be okay. I mean, there isn't any accumulation on the ground, so it probably doesn't snow that often, right?
False.
Well, across all the days we were here, it snowed every single day. Again, for an average of around 11 hours per day. At least there was a little less heavy snow this time. But that's still total to an average of 2,808 inches or around 71 meters. And that's only 100 inches less than the mountain, which gets way too much snow, and this still gets way too much snow. This is another purple rating. I guess this isn't really acting like the buffer we were hoping for. Man, we were doing so well. The rainfall amounts were actually looking pretty decent. Apparently the team that coded the rain did not have a phone call with the snow team. They didn't get the memo at all. Well, at least we are done with the snowy areas. And if we go a little to the what? Origami Hoshi is evolving? Hey, stop that. We're trying to do science here. Jeez, in the middle of a video. Where was I? As I was saying, there are some forested areas to the east, and I can already hear the comment section saying, Papa Goron, you can't lump those together. Bamboo forest and deciduous forest don't get the same amount of rain. And technically that's true, but Origami, do you mind? Anyway, but temperate deciduous forests tend to get between 40 and 60 inches of rain per year, while most bamboo forests are wetter. But if you live in the eastern US or parts of Europe like the UK, France, and Germany, you know that bamboo does just fine in lower rainfall areas. That's because bamboo primarily needs water for rapid early growth, and once it's established in an area, it's incredibly hard to get rid of. Really? Again, Origami, are we gonna do this after every battle? Anyway, that's because bamboo is highly invasive and grows easily in areas with fewer than 60 inches or 1.5 meters of rain per year. Invasive species don't just survive in their new ranges, they actually outcompete the natives. That means even though bamboo's native range in China gets up to 160 inches per year, bamboo can still thrive in drier climates. Stick around to the end of the video because we'll talk about why this bamboo patch is right in the middle of all these deciduous trees. So if temperate deciduous forest usually gets up to 60 inches of rain per year, what about in Paldea? Origami! That is it! I'm over this! Where is my Everstone? Eat this and splash around, okay? If you're good, we will get ice cream after all this research, okay? All right. Well, in Paldea, it rained 85% of the days we visited the forest for an average of 1.72 hours per day. That means they are getting 188 inches or 47 meters of rain each year. That's not temperate forest levels. This should be a full tropical rainforest, and that's another solid dark blue rating. Hopefully the next areas have a little less rainfall. Otherwise, Paldea is about 3 storms away from needing to call FEMA. South of the forests of Paldea lie 2 dry canyon areas, and interestingly, these areas bear a striking resemblance to the Red Canyons in Spain, also sometimes known as the Spanish Grand Canyon, which is an interesting nickname, because while both canyons have steep cliffs and iron-rich red soil, they were formed in incredibly different ways. In the American West, the Grand Canyon formed through a combination of tectonic uplift and erosion. As the land rose upward, the fast-flowing Colorado River gradually carved a channel through the rock over millions of years. But in the Red Canyons of Spain, the process was different. These badlands were formed by flash floods. In an environment where it almost never rains, and when water does finally come, it tears through the soft red clay, carving these jagged cliffs and gullies in a matter of hours instead of millions of years. Talk about efficient. If geological time always worked that fast, we'd still be riding dinosaurs. Oh, wait. So if these canyons are formed by intense flash floods, we should be expecting no rain on most days, and we should almost never see a heavy storm. In fact, this area of Spain usually gets 300 to 500 millimeters of rain each year. That's about 12 to 20 inches. And the crazy part? All that rain falls in just a few storms. The rain falls harder and faster than the dry soil can absorb it. So instead of soaking in, it runs down the steep cliffs, taking tons of dirt and rocks with it. So does Paldea hold that up? Nope, not even close. It rained almost every single day in the canyons for an average of 1.3 hours. That comes to 150 inches, or 3.8 meters. That's 10 times more rain than an area like this should have. And that leaves us with some questions, because usually when we see areas with low vegetation like this, it's because there isn't enough rain. See, every biome on Earth has a highly predictable climax community. That means that if you know the temperature, you can predict what biome should be there. Even after a disturbance, like a flash flood or fire, the same type of biome will grow back. This process is called secondary succession. So in a place with 150 inches of rain, even if some apocalyptic Pokemon wiped the whole area out, the rain would restore life. I mean, unless that Pokemon was like, gonna blow up the entire planet, then, there's no rain at that point. Is Frieza a Pokemon? Grasses first, then bushes, and other shrubs. Next, fast-growing evergreens will grow, and finally, the tall, slow-growing deciduous trees take over. And at its climax, as our next dark blue rating, this place should look like the Pacific Northwest, a temperate rainforest. And that's it for the surface. But we're not done yet, because there's still one other place the rain in Paldea could fall. Area 0. While a lot of Area 0 is inside caves, the area directly at the bottom of the crater should be exposed to the rain above. And at first, we were expecting to get the same amount of rain as the grasslands or the highlands nearby. But then we realized something. It never rains in Area 0. How is that even possible? I mean, sure, there is a thick cloud layer, but if the sun can penetrate it, rain should definitely be happening, right? Well, sort of. See, deep craters can actually do some pretty cool tricks. Whoa! That was a pretty dope kickflip. And as it turns out, there is a very specific scientific reason why this area might stay bone dry. And it has something to do with that steam layer you see hovering halfway down. You might look at those crater rims and think, hey, those are probably only a few hundred meters high. Surely a stray rain cloud could just wander in? Wrong. In fact, those clouds are fighting a losing battle against physics. So how does this work? How do you keep a giant hole in the ground from ever getting wet? Well, the answer is something called adiabatic heating. That's when air increases temperature from compression instead of heat. So what does that have to do with a giant crater? Well, when air from the surface tries to drop into the crater, the atmospheric pressure starts to ramp up. As the pressure increases, the air gets compressed, and when you compress a gas, it gets hot. It's basically the same thing that happens when you pump up a bike tire and the nozzle gets warm. But here's the trick. As the air warms up, its capacity to hold water skyrockets. So instead of that moisture condensing and falling as nice, refreshing rain, it does the opposite. It evaporates. Any rain droplet brave enough to fall into the crater hits the wall of rising heat and vanishes into thin air before it ever touches the grass. Meteorologists have a name for this ghost rain. It's called virga. You're literally watching the rain evaporate in mid-air. Access denied. So those clouds inside Paldea's Great Crater? Those aren't rain clouds or volcanic smoke. It's a raindrop graveyard. Which, hey, by the way, Nintendo, if you're taking a look at this video, have to say, if you want to make a really cool Pokemon, Ghost Raindrop, that would be pretty cool. A water ghost type? I'd be down. Pokemon, listen, Ghost Water Drop, that would be really cool. Anyway, the result? The bottom of the crater stays perpetually dry, while the clouds just float above, completely unable to break through that layer of hot air. And that's how you would create a desert in the middle of a hole in the ground. But then, why is it so green down here? If it never rains, shouldn't this be like all desert? Well, luckily, there seems to be a lot of waterfalls here, which makes sense. I mean, they are probably coming from the nearby groundwater. And with all that rain in Paldea, there should be a lot of it. So with that, we are going to give Area 0, the central crater, an orange rating. Wow, this isn't actually that bad. I mean, none of it is accurate for real-life rainfall, but compared to other games we've looked at, this is not too bad. Okay, but what exactly have we found here? Remember, we estimated light snowfall at about a ½ inch per hour, heavy snowfall at 1 inch per hour, normal rain at 0.3 inches per hour, and heavy rain at 1 inch per hour. And these were all conservative estimates, meaning they were at the low end of the range. So here's how that data shook out. In the blue, that's the average rainfall for Paldea, which means in some places it rained even more than that. And in the red, that's the maximum recorded data for Earth, the max. For reference, the wettest place in Spain is probably San Sebastian. They can get rain up to 220 days per year, but even then, they only get about 1,500 millimeters of rain per year. That's 59 inches. In the real world, that is a lot of rain. But look at Paldea. Even the dry farmlands are getting more than that. And don't get me started about the snow. Look at this. We had to graph snow completely separately. You couldn't even see the other regions on the graph. Wow, that's a lot of snow. This much snow would absolutely crush mountaintops. Remember Amori, Japan from earlier? They get almost 700 inches of snow per year. And there's nowhere else on Earth even close to that. But that still pales in comparison to the 2,909 inches recorded in game. Mount Glacido is not just snowy. It's on an entirely different scale of absurdity. But are there any real-world ways to account for this much rain and snow? Maybe. See, when rain falls on the ground, it has a few options. The first is percolation. If rain falls on a dry ground, the ground acts like a sponge. It greedily soaks up the water, filling up the tiny spaces between the grains of dirt. This is how groundwater is formed. And based on the massive waterfalls in the crater, I would say a lot of rain is becoming groundwater. The second option for rain is runoff and storage. If rain falls faster than the ground can soak up, it starts to travel downhill. If you watched any of our water quality videos, you know about runoff. And when the water reaches the bottom, it gets stored in lakes, rivers, and oceans. And that definitely could be happening here. I mean, Paldea is surrounded by ocean. But wouldn't all this rainfall mean the ocean levels would be rising fast? And the crater would be flooding? No. See, if we ignore the snow for a minute, most of the rain in Paldea could exist on Earth. The biomes don't match, but it's not impossible levels of rain. And that means that evaporation could be keeping up with these levels of rainfall. And that's our last option for rainfall. When rain hits Earth, eventually it evaporates again. And as it heats, it rises up in the atmosphere where it cools and turns back into clouds. And eventually, more rain. So is the water cycle in Paldea just really fast? So the rain falls and evaporates really quick? Or is there something else at work here? Because we are really stuck on the issue of secondary succession. If it really rains that much, why isn't there more plant life? Wait. Plant life. What if Pokémon are the extra plant life? What if all that rain, instead of growing trees, what if it's growing plant Pokémon? There are so many Pokémon that are photosynthesizing. There's even an olive tree Pokémon. Could that be accounting for some extra water? And what about non-plant Pokémon? Could Pokémon help literally maintain the environment on the island of Paldea? Oh man, is there anything about the lore of Pokémon Scarlet and Violet that could explain this mismatch between the amount of rain and the plant life we see in Paldea? Well, I'll be honest with all of you. I'm a scientist. I'm not a Pokemon lore master. But you know, when I think Pokemon lore master, only one person comes to mind. Someone who has been making Pokemon lore videos for over 10 years. Lore Keeper Toby. And so we reached out to Toby to get more insight on this Pokemon environment enigma. And what we learned was shocking. You probably know that there are many Pokemon that can affect weather. And if you played Pokopia, you know that even Slowpoke can make it rain. No, Slowpoke, I meant like actual rain. Aww. Can you imagine it rained every single time an animal got sleepy? I mean, my kitten would make it rain all the time. It would be a flood around Death Mountain over here. And what about Rain Dance, the move? I know Squirrel's Rain Dance in Pokopia wasn't that dramatic, but usually the move Rain Dance makes it rain. And there are about 200 types of Pokemon that can learn this move. No wonder Paldea has so much rain. I mean, it's probably a Pokemon disco over there. And even more than that, the legendary Pokemon Kyogre apparently has the ability to create decades of drought or restore rain just by taking a long nap. That's going to be a hard one to explain with science. Which is why we usually stick to things we can observe. We like nice, observable, well-behaved science. But sometimes, when the observable is unexplainable, knowing a little history can help. And that's exactly what Lore Keeper Toby gave us. The history of Paldea and the legend of the Quartet of Ruin. And if you're interested in the deeper parts of the history and lore, I would highly recommend you check out his video that's linked in the description below. His video, though, is very enjoyable and honestly inspires me to do even more research into the world of Pokemon. So again, maybe consider liking and subscribing. We've got a lot to do here. But how can the history of Paldea tell us why there aren't more trees? Well, it all started about 2,000 years ago. The Paldean Empire existed from around 2,000 to 800 years ago. And sometime during that period, the Pokemon of Ruin were created from artifacts. Geez, Quartet of Ruin is a pretty intimidating nickname. Would actually be pretty sick as a rock band name. So what exactly did they ruin? Well, if you watch Toby's video, pretty much everything.
Whoa, I think I just figured something out, Beavis.
What?
This sucks.
Yeah, it really sucks.
This sucks more than anything that has ever sucked before.
Yep. Yeah. Good job. Remember that clap we were going to give to Pokemon? Yeah. No. Give it to these guys right here. Good job. Way to ruin everything. Thanks, Quartet of Ruin. See, Tauros? It's not just you. Let's start with Chi-Yu, the firefish. According to his Pokedex entry, this fish can create rivers of lava, and that clearly points us to the northeast near the forest biome. That's because we can clearly see spires of obsidian glass here. Obsidian is an igneous rock, meaning it's made from cool lava. And what's more is this kind of formation is called an igneous intrusion. These are created when magma fills cracks or melts through an area of rock. That means you will see obsidian cutting through a different type of rock. Geologists use this principle of cross-cutting to define the intruding rock as younger than the rock it cuts through. So at some point, there were rivers of lava in this area cutting through the original rock. Okay, but this is a rain video, not a lava video. How is this related? Well, it turns out magma is really bad for plants. Who knew? But remember that secondary succession we talked about earlier? Well, if there's something simple like a flood, the plants can recover fairly quickly. Some plants survive, and the dirt and roots are often intact. But hot lava, as you imagine, is totally different. When lava cools, it creates a completely barren new rock with no soil or available nutrients. And that's where primary succession comes in. Primary succession has to start by making dirt. And that's the job of bacteria, mosses, and lichens. Once there's dirt, ferns and grasses can start to move in. But there's a catch. Secondary succession only takes a few hundred years. And Lore Keeper Toby said this was likely 800 to 1500 years ago. So why isn't everything forested? Well, primary succession can take thousands of years for the climax ecosystem to form. So if there were any lava creating Pokemon around, it could definitely help us understand why the rain and the biomes don't match at all. There just hasn't been enough time for all the trees to grow back. Also, remember that bamboo? Well, it was likely brought to Paldea at the same time as the artifacts from the east. And just like on Earth, if it's warm and wet enough, bamboo will take over any environment. Again, it's invasive. But what about the other regions of Paldea? How did they get so messed up? Well, if we keep moving north, we come to the Glacido Mountain, and likely the ancient home of Chin Pao. His Pokedex entry states that he could create avalanches and control 100 tons of snow. Now, I'm not trying to criticize one of the Pokemon in Ruin, but 100 tons would be pretty small as an avalanche. According to the European Avalanche Warning Services, this would barely be larger than a small slough or unlikely to actually bury a person. But if Chin Pao were continuously bringing 100 tons of snow, he could definitely affect the local water cycle. While we normally think of evaporation and rainfall on a global scale, local water cycling works just like global water cycling. But this time, the water stays put. In a local cycle, the water evaporates and comes right back down as snow or rain. And the shocking part? This accounts for about 2/3 of the local rainfall. So, if Chin Pao were bringing in moisture from his avalanche extravaganza, he might have brought a lot of moisture to the mountains, even 1,000 years later. And that might not be the only way the Quartet of Ruin were messing up local cycles, because just to the east is a giant lake. But according to Lore Keeper Toby, it might not always have been here. See, the third Pokemon of Ruin is Ting Lu, and the huge vessel on his head could be used to carry enormous amounts of water. Look, I know that it doesn't look like a big bowl, but it's It's magical, okay? We're not gonna get into it. Pair that with Tinglu's Pokedex entry, and you have the makings of a lake. In Pokemon Violet, it states that Tinglu can use its heavy head to make fissures in the ground 160 feet deep. But if it did get enough water to make a Lake Casseroya, where did all that water come from? Well, potentially from the southeast. These southern red canyons might once have held water. Why? Because finding Neckley here is evidence of an ancient shallow lake or inland sea. Neckley is a rock salt Pokemon, and rock salt forms through the evaporation of a very shallow body of water. So perhaps this area was once underwater. If Tinglu stole most of the water, only a shallow lake would remain. And that lake could have evaporated over hundreds of years, leaving behind nothing but salt. And our cute little Neckley here. And this theory helps explain two things. If the soil to the southeast is salty, that might explain why almost nothing can grow here. That's because salty ground causes osmotic stress. What? Osmotic stress happens when a plant can't maintain enough moisture in its roots and shoots. The plants literally die of dehydration, even if it's raining. And that's because water always follows salt. So, if there is salt in the soil, the water will flow out of the plant and into the soil. Talk about salting the earth. Don't worry, Neckley. I still really like you. It's a cool Pokemon, okay? I don't care what it says. And this theory also helps explain why the northern grasslands get so much rain. If that lake didn't used to be there, carrying all the water from one side of the map to the other would certainly affect the local water cycle. So what about the last Pokemon to ruin? Wo-Chien. According to his Pokedex entry, it drains the life force of vegetation, causing nearby forests to instantly wither and fields to turn barren. That's not great for the plants of Paldea. But surely, after 800 years, the fields would have recovered, right? Well, it depends what barren means. See, fields aren't just the grass, and the forests aren't just the trees. The soil is also alive. It's alive! And usually, when a field is barren, it's because the soil is dead too. Soil is full of bacteria and fungi that help plants get the nutrients they need in order to grow, especially nitrogen-fixing bacteria. These are the only living organisms on Earth that can turn inorganic nitrogen into organic nitrogen. And without them, life on Earth would cease to exist. Once we used up the remaining organic nitrogen, everything from the smallest blade of grass to the largest blue whale would simply not have the building blocks to grow. So what if Wo-Chien didn't just destroy the plants? What if he destroyed the soil microbes too? Well, it would take thousands of years for that area to recover. No wonder Paldea looks like it's only halfway through secession, and why we only see grass where there should be lush forests. So, is the rainfall in Paldea disastrous? No, not at all. The snow on the mountain might be a problem, but at the rate it's melting, it could be providing Area Zero with the water it so desperately needs. And the rest? Well, the rainfall in Paldea might be the only thing keeping this once ruined countryside alive. But what do you think? Does it rain too much in Paldea? Could the water cycle really be moving that fast? Or are the citizens of Paldea just praying that Kyogre doesn't take another dive? Seriously, wake it up, dude. Let us know down in the comments below. And while you're down there, don't forget to like, subscribe, hype the video, check out our Discord and Patreon. And again, a huge special thanks out to Lore Keeper Toby. Thanks for answering our questions. It really just helped us so much with this video. And remember everybody, stay dry out there. My name is Papa Goron. Thank you so much for watching, and I'll see you on the next one. Bye.
Where have you been? Been searching all along. Confusing twilight on and on. Without a clue, without a sign, without grasping at the real question to be asked. Where have I been? I'm a shapeshifter at post masquerade, hiding both face and mind, all free for you to draw. I'm a shapeshifter. What else should I be? Please don't take off my mask, revealing dark. Moments of calm, nothing left to be found.
Still no rain. Still no rain, Sliggoo. Sliggoo! It's been a whole day in real life now. Jeez, we are never going to get the shiny charm in this game, Sliggoo. Sliggoo! Sliggoo! You know, while we're waiting here, I heard that Legend ZA actually has a lot of fun shiny hunting. Sliggoo! I bet you could evolve there a lot faster, too. Sliggoo! You know what? Come on, Sliggoo. Let's go to Lumoy City. We'll get some water there. Sliggoo? I bet the water quality is pretty nice there, too. Sliggoo? At least, I hope it's safe to drink. Just, hey, when we get there, if you could ignore the window textures. They don't look so great like the mountains here in Paldea.
I'm a shapeshifter at post masquerade, hiding both face and mind, all free for you to draw. I'm a shapeshifter, chained down to my core. Please don't take off my mask,